I'm Paul Morin with the Energy Conservatory, and this is part 3 in a TECLOG series. And this is an advanced TECLOG session titled Testing Multifamily Buildings. If you're having trouble with your audio, go to the Meetings pull-down menu and choose the Audio Setup Wizard, and that will step you through how to get your audio up and running. And please type in questions as you think of them in the question and answer section on the right. And we will be answering, typing in answers to questions as we go through the webinar, and then we'll take some time and review those questions and take additional questions at the end. There will be a link to our webinar on our website. We usually get that up within a couple of days, so if you want to view it again or share it with others, you can feel free to do that. And then give us feedback on what type of webinars, or if there's additional information on multifamily testing using TechTite that you'd like to see. Give us some feedback, and we like to provide you with that information. As I mentioned, this is a third in a 4-part series, and the first part was on just a basic intro to TECLOG, showing you some of the features and using it to data log pressures. The second session was about just doing a simple single fan blow dryer test and then importing that data into TechTite Express to create a report. And the next series will be on testing larger buildings as in single zone conditions, and also we'll cover a test where we've got one section of that building that's a separate zone, and we'll be doing a fully guarded single zone test using 2 zones. We'll be talking about different testing options. There's a lot of different ways to test a multifamily building, and the configuration worksheet, where you're gathering all the information from all the DG700s and all the channels and entering that. You're gathering all the information you need to enter into the TECLOG3 software. We'll talk about options for connecting multiple DG700s to a computer. And then we'll do an example test of a 2-unit building. And then we'll review the results. So to get started, you can download a free version of that TECLOG3 software from our website, go through the setup process, and launch software and try it out. So testing options, there's 3 basic testing options, and we'll go into this in a little more detail. But the first one is testing unit by unit. It's often referred to as a compartmentalization test. You're trying to compartmentalize unit by unit, and there's certainly a lot of advantages to that. But we don't have time in this session to go into detail. And then there's what's referred to as a guarded test, and we'll talk about that in some detail, and then a fully guarded test, and we'll talk about some different options for that. So we're showing two basic types of buildings in these images here. The first one on the left is 6 units per floor, with a common hallway, 2 common entrances, and this type of building is very common in northern climates, in the upper Midwest, and probably throughout the country. And this could be 2 stories or 3 stories. It could be multiple stories also, where you have units above and below. And then the one on the right is more sometimes referred to as garden style or townhouse or row house type building, where there's no common entrance. You can only enter that building from the outside, and it might be a walk-up where there's multiple stories. There could be units back to back also. So we'll be talking about some testing options for that. So there are different options for single unit compartmentalization tests. You could have adjacent units open to the outside, and some testing standards require that any adjacent unit needs to be open to the outside. Or you may be testing it with windows and doors closed. The door to the hallway, where it has a common hallway, would be closed, and then any windows in the unit would be closed. So this is showing an example of where you have the adjacent spaces. So the center one is our test unit that's in blue with the blower door set up to the hallway, and we're depressurizing that with negative 50 pascals with reference to the outside. And all of the adjacent units have either windows open to the outside or doors open to the outside with doors open to the hallway with doors open to the outside on each end. So the adjacent units, you can monitor pressures in there. They should be 0 pascals to the outside or close to 0, and the hallway should be 0 pascals because that's adjacent. And the units above and below would need to be open to the outside. So you're seeing 50 pascals to each adjacent space. 50 pascals to adjacent units, to the hallway, to the unit above, unit below. And then in a townhouse style, row house style, we're showing that also, where the adjacent units have doors or windows open to the outside, so the pressure is the same as the pressure outside, and we're seeing 50 pascals to all adjoining spaces. And then the other option would be if it's not showing the doors closed here, but it's being tested with doors closed to hallways, doors closed to between hallways and adjacent spaces, windows closed, and it's just being tested as it is. So this is being depressurized 50, and we might see anywhere from less than 1 pascal up to 20 or 30 or even 50 pascals, depending on how well interconnected they are to the adjacent units. So the pressures are what they are, and in this example we're even seeing pressures a couple of spaces down when we depressurize 1 to 50. Now this one is showing what's referred to as a guarded test, where any adjacent spaces, so any space that has an adjacent wall or an adjacent floor or an adjacent ceiling, are depressurized to 50 pascals. So the theory is, if the pressures across the common walls are the same, they're both at 50 pascals, then there should not be any airflow across that wall, because for airflow you need both a pressure and an opening. You need both to get air movement. So the theory with this is, any adjoining space you bring up to the same pressure, and then you're measuring leakage to the outside. One of the flaws that you may have picked up on already with this theory is that because you have all adjacent space at 50, doesn't mean there isn't any cross leakage between this test unit and maybe all of the units across the hall, or all of the units of the above floor, depending on the framing techniques and sealing techniques that were used. Usually in newer buildings they do a pretty good job with firewalls, but those of you who have tested across firewalls know that they're not perfect either. So there's supposed to be firewalls between adjoining units, and there certainly is change in air pressure when you run a blower door test. So but this is referred to as a guarded test, where all adjacent spaces are at the same pressure. Trying to zoom in on just the air leakage to the outside from that test unit. And we're showing that. So we're showing, in this case, we've got a blower door set up in each adjoining unit, and if we had units above and below, we'd have, in this case, we would have a total of 1, 2, 3, 4. We've got one set up in the hallway, and we'd have one above and below. So we'd have a total of 6 blower doors set up to test one unit. And then, as we wanted to test another unit, we would rotate blower doors around and do another test. And the second one here is showing with no common hallways. If you're testing a middle unit, you've got 3 fans set up. If you're testing the end units, you would just have 2. And again, this is so whatever the test unit is, you need to have 50 pascals on to each adjoining unit. You do certainly, if you've got a crawl space or an attic, there's going to be air leakage through those spaces, and this space will be depressurized somewhat, and the value of your test unit may be different if you have the 4th one depressurized also. So that kind of gets into what a fully guarded test is compared to what a guarded test would be. So with a fully guarded test, the first example with a common hallway, what you would do is open the doors to all of the units and use blower doors to depressurize the whole building to 50 pascals. And you can test with a 3-fan system. If you're trying to meet an energy code at 3 air changes per hour, you could test a 36-unit apartment building with 3 blower door fans. So you can test get a pretty big building up to pressure with a 3-fan system. And so once you get the entire, you're not concerned about the flow at all through these 3 fans. You're just interested in setting those to cruise 50, and then you set up a blower door in each unit and measure with respect to the hallway and bring that up to the same pressure. So the same pressure as the rest of the building. And that gives you the leakage. You'll only get the leakage to the outside with that blower door now, because all adjoining spaces are at 50 pascals. So as you can see, that would be a test where in this case would require less blower doors. You would only need 4 instead of 6 to test this particular building, and it would certainly be quicker if you set up in the hallway and just move this fan from room to room to room to room, move it up a floor, and it'd be quicker, easier, less fans, less time, and more accurate test. And then the one with the common hallway, also instead of if you've got a 8-unit row house and you have to keep leapfrogging with the fans to get your numbers, that could be time consuming. Sometimes it's easier just to set up all the fans and less setup time, less time to run the test. You just bring them all up 50, get the number, and then pack up. Does need more fans though. So next we'll be talking about connecting a computer with multiple DG700s with wired connections. You would typically do the 9-pin serial to USB, and so this is showing an 8-port hub, and the DB9, the 9-pin serial to Cat5 adapter. So you attach this to the top of the DG700 and then just snap the Cat5 Ethernet cable into the top, and you can run thousands of feet of cable. The cable length is really immaterial in this case. And then you can get either 4-port, 8-port, or 16-port serial to USB hubs that you can use, and then you have a single USB going to the computer from that hub. So that's how you make those connections. If you're doing wireless, you can only connect to one wireless network at a time. So those DG700s will need to be configured to router mode, and that can be done in TECLOG and TECTITE, or using the iTech 700 app for Apple or Android. You can configure the gauge to router mode using that software. So then all of the DG700s will talk to the router, and the router we've had good luck with and the most experience with is a simple Apple Airport Express is the name of it, Apple Airport Express. And they run about $100, and we've had real solid success with that router. And then you connect via Wi-Fi between the router and your computer. This is showing the configuration worksheet. That's it's available in the help menu of TECLOG. So if you go up to the help menu, you can print that off. And this allows you to draw a sketch of the building and where you have the fan set up, and which way's north, and the tubing connections, and draw that kind of detail up in this area. And then there's room to put data for 16 DG700s. That's the max that you can do in TECTITE. If you go beyond 16 DG700s, you would need to run 2 versions of TECTITE on your computer, or run TECTITE on multiple computers to get to be able to do more than that. So what you need, the information you need to enter into TECTITE is the serial number of the DG700, because the software will recognize the gauge by its serial number, and then give that DG700 a label based on where it is, or what it's being used for. And then each channel, you'll need to tell it what you're using that for. Is it a envelope pressure? Is it the envelope pressure on the north side of the building? Or is it a fan flow? Is it a duct blaster fan flow or a blower door fan flow? So you'll need to gather that information, and certainly it's best to do that after you've got everything set up. You might be monitoring internal pressures, and there could be any variety of things that you're measuring. Once everything is set up, gather all that information and then start entering it into TECTITE. So we're going to do a TECLOG test example. We've got it'll be a 2-unit building. We'll be measuring 1 envelope pressure for each unit. So basically, it's like setting up for 2 single fan blower door tests. Setting up 1 fan in each unit, where we've got an envelope pressure and a fan pressure for each fan. We'll do a fully guarded test first, where we have the same induced pressure in both units, and then we'll do we'll do the 2 single units separately. So we'll do compartmentalization single unit tests. We'll do 2 of those, one for the first unit, one for the second unit. And this is an example of the TECLOG configuration worksheet filled out. So we're showing that in Unit A, we've got a blower door set up and a one DG700, and we've got channel A as our envelope pressure going to the south side, and on channel B, we've got we're going to the fan flow. And similar on Unit B, we've got one blower door, one gauge, and channel A is measuring an envelope pressure, and channel B is going to the fan. So we fill out the information, gather all that information in our worksheet, so we can enter the information we need into TECLOG. So we need the serial number of the gauge, because that's what the software recognizes, that serial number, and we're going to label the first one as Unit A, so that's our Unit A DG700, and we're also labeling channel A our envelope pressure, that's our Unit A envelope pressure, and channel B is our fan flow for fan A, fan in Unit A. And you can use whatever naming convention you like, as long as you understand which one is going to which. And then in Unit B, we've got our second DG700. We entered its serial number, and we labeled that one simply Unit B, and our channel A is our envelope pressure for Unit B, and then fan B. So pretty straightforward, but when you have larger buildings with multiple gauges, multiple fans, you need to keep all this straight. And it is typically best, once you have everything set up, to go around and label things. If you find out when after you have most of them set up that you have to start moving things around, then it can get confusing. So it's best to set everything up, maybe even run some test pressures and make sure that's going to work before you start writing down all this information and then have to change things around later. It gets confusing. So wait till everything is set up in its final condition, and then write all these things down. For this TECLOG3 test, we have 2 gauges. One will be connected via Wi-Fi and one via cable. So I'll go down to our network connections, and we see our DG700 along with its serial number, and we'll connect to that. And we'll launch our TECLOG3 software. And when we made that network connection, if we were connecting for the first time, we'd have to enter a serial number. Then I'll go to the configuration pull-down menu, configuration settings, and we'll set our 2 devices here as DG700s, and then we'll scan for ports and devices. That wired connection, because I've got it connected to an 8-port hub, it's going to find all of those communication, those COM connections, and it will list them all and show that they're available, and then it'll find the one with the DG700 connected to it. After it's done listing all the available channels, it will start searching for the Wi-Fi links, and once it finds that, our COM port test will be done. So we found 2 energy conservatory devices. Click OK, and now we need to enter the serial numbers in, and each gauge has a chip in it that has its serial number that the software is recognizing, and I'll choose one of those, and we'll label that one Unit A. And then I'll double click on the second one, and you can see this one's grayed out. It's really helpful if you've got a list of 10 gauges. It grays them out as you choose them. And we'll label this one Unit B. Okay, and then we'll click down here on View and Edit Channel Settings. We've got the gauges configured. Now we need to configure the channels. And you can see we've got two tabs up here, one for each DG700. On channel A, we've got an envelope pressure, and I'm going to label that Unit A again, so we know which pressure that is. And you can see it changed the default color to green. And then on channel B, we're going to call that a Model 3 fan flow. Change the color to the default red. And we'll call that A fan. And I'm going to adjust our cruise settings here to the fan start. I'm going to go up to 50 because they're going to have to ramp up to a pretty high rate, and that'll just speed it up a little bit. And then I'm going to click on the second tab for the second gauge to configure the channels. And channel A again, we've got interior pressure. Oops, we've got an envelope pressure. We'll get into interior pressures when we're talking about big building testing. That's where those numbers get critical when we're doing a single zone test. And we want to make sure pressures throughout the building are in single zone conditions. And on channel B here, we will click on Model 3 fan flow. And we'll label that first one Unit B, and the second one B fan. And you can come up with any type of labeling that helps remind you which channel is which and which fan is which. And then we'll click, oops, we'll change that cruise setting to 50 again, so that'll ramp up and speed up our test a little bit. Click OK, and then I'm going to click OK to close out the channel settings. And we're going to set our test standard to the CGSB. That's the one most of you are used to using for residential testing. And that has you test at 8 channels starting at 50. We're going to speed it up for the sake of the test, and we'll just do 30, 40, and 50 instead of starting at 55 and going down 5 at a time to speed up the time of the test, just so you get a feeling for how to do the test. And then we'll go to recording, pull down menu and click Start Recording. Now it's going to do the scan for all the devices that are connected, and it will enable them so we can start transmitting data and start graphing our pressures and flows. So again, we're testing 2 units, and we're only using 2 outdoor references, one for each fan. So it's just, we're setting up similar to just running 2 single fan blower door tests. We'll give this a name. We'll call it Test AB. Save that to our desktop. Okay, so now we can see we're starting to graph our pressures. So I'm going to start a baseline period of record. And the baseline periods of record are set for 2 minutes. So we'll call this a pre-base. So you can see it outlined in green, a 2-minute period of time. And you can see we have 3 slide controllers here, fan controllers, and 3 cruise targets. We're not going to use the master. The master is for if you're controlling both fans with 1 bar, but if we did that and they're both brought up to the equal rates, we'd have different pressures in each unit unless they're exactly the same tightness. So so what we'll do is we'll go and we'll unlink those from the master controller. So the control of them, we can control them separately. So I'm going to click unlink. and OK. And then I'm going to close out that master controller. We can do that by going up to View and unclick on Show Master Control. Now we've got just those two showing. And now we can see our unit in green, our unit A and B pressures are showing up here, and our we can see our fans are sealed. Both of our fans are sealed for our baseline period of record here. So now I'm going to start out doing a test with the fans in both units running, and so we'll be setting both units to cruise, and then after that test is complete, then we'll do the unit separately. We'll seal the fan in one unit and test in the other. Now I can see it reminds you to add 0.5 pascals to our envelope pressure, so we're actually inducing the pressure by 50 pascals. So it's saying to add 5 pascals, so that's a reminder. But what we're going to want to actually do is I'm going to click on the period of record, and it shows that one of them was at 0.3 and one was at 0.8. So I'm going to add 0.3 to unit A. So we'll call that negative 50.3. So that unit will be induced by 50 pascals. And then 0.8 on our next one. So that one is induced by 50 pascals also. And then we can mark these. Oops, I'm going to click out of that period of record to do that. Channel A, in channel A, and now I'm going to go uncap the fans. Okay, our fans are uncapped, so hit our cruise fans. And I'm going to help these out a little bit to get the pressures. So what I'm looking at now is these two pressures, and I'm trying to get those close to the same amount so they don't start fighting each other. It speeds up the process a little quicker to get them pretty close and then let it settle out from there. So I'm going to click Auto T and Auto Y here, just so so we can see both the fan pressures and the envelope pressures on the screen. So the fans are gonna make some adjustments for a little bit till they come into sync with each other. When they're both at about the same pressure, there'll be very little flow between the two units. So once they kind of come into sync there, then we'll click fan on period of record. And we'll call that our negative 50 pressure. And the fan on period of records are 30 seconds, so it'll go for 30 seconds. And we can see our flows are pretty close to each other. We've got 2100 in unit A and 1750 in unit B. Okay, so now I can click these up. We're going towards 0, so we want to click up, and I'm going to do 2 clicks. It moves 5 pascals with each click. So we're just going to do 50, 40, 30, and and then check our results. And normally you do start at 50 and go down 5 pascals at a time, and go from 50 all the way down to 15, but we're just going to do 3 points to speed it up a little bit. Now I'll click fan on, period of record, and this is our negative 40 point. Okay, and then I'll click the up arrow, so there's an up arrow and a down arrow depending on which direction you wanna go. I'm gonna click the up arrow twice for each one, and then it'll adjust to 30 pascals. So it's not quite as automated as the Tektite software, but it's still, it gives you a little more control over when you start the periods of record and when they stop. You can kind of make sure everything is looking good on the graph. It's nice to be able to graphically see what's going on too. Okay, looks like our pressures are pretty stable there. So I'll click our last fan on period of record and call that negative 30. So we can see it displays the total flow here. We've got 2 fans running. We've got 2 available and both are running. So it shows that, and then our average envelope pressure between the 2 units. So now we can, I'm going to click on results here. We can see our test results, and we can see they're lining up really close on our line. We've got a really good correlation coefficient. It's not very windy. Wind isn't really affecting it today, and it shows the total flow through both fans. So this looks like a good test. So we'll click OK, and then I'm gonna turn the fans off, and then I am going to seal one of the fans here. So I'll go seal that one. Okay, and then I'm going to pull this over. We can zoom in or out or go back and forth just like you can in Google Maps. So I'm just going to pull this over a little bit farther. Now we sealed off Unit B, so now we're going to do a single fan test on Unit A. So we'll just click that up to 50. Whoops, got to go the right direction. I'm going to click that to 50 pascals, and we'll just do a 1-point test at 50. Set that one to cruise. And I'll help just pull that one up so it's 50. So we're looking for 50 pascals on this is showing our average pressure, but our average of the 2 envelope pressures of 2 channels. But we're just looking, we're only doing 1 at a time here, so we're looking at our number there. I'm going to do auto Y again so we can see if our fan is planed out. It looks pretty good. So I'm going to do a period of record for Unit A. And I'm not going to include this in our air tightness results. Otherwise, that'll jade our numbers on that line. So that's not going to be included in the air tightness test. We're just doing the test on the individual unit. So we're going to click OK. And then we'll do the same with unit B, where we'll cap the fan A and uncap fan B and run that test. Okay, so I'm going to stop, turn the fan off, and we are going to mark this one as sealed and mark this one as ring A, and I'll go get those fan caps set up. Okay, now we'll set our cruise target to 50 for our unit B fan, and we'll hit cruise fan, and we'll let that one get up to 50. I'll pull that along to help speed it up here. And now we can see our unit B pressure here is, we overshot it a little bit, so now it's backing off a little. I'm going to pull our scale over again. So we're down to 50, 51, 52. I'll pull it back just a little bit. There we go. And on period of record. We'll call that unit B. And then after it takes its data for unit B, whoops, I noticed that this one is dotted and this one isn't. So I'm going to click in that period of record and I'm going to edit that. So this is how you would do that. Click in that period of record so it gets a white outline. Click edit period of record, and I'm not going to include this in our air tightness test. So it didn't like that. So we're gonna start that fan on period of record again. We're gonna click to not include it in the period of record, and we're gonna call that unit B. So it's kind of good some of these things come up during the test. So, you know, we've got teachable moments when things like that happen. So that went pretty quickly. So now we've got our unit B period of record. So I'll stop that fan off. And we'll stop recording. And we do want to stop the data transfer. And we want to load the file we just created. Okay, so we can look at our results again. See what our total flow, so our total flow through both of them is 38 CFM total for when both fans are on. And we can go to our unit A period of record, Unit A here, and we'll click, do a left click and then a right click in there, and we'll choose Show Stats. And it'll show all the statistics for that 30-second period of record. And we can see that Unit A was at about 50.8, and our flow was 2288. So write that 2288 for Unit A. And then I'll click, do a left click, and that gets makes a white outline, and then I'll right click inside that white box and click Show Stats. Now we can see Unit B was at about 52, so we'll want to make an adjustment on that back down to 50, and our flow was about 1785. So we had 2288 and 1785. That equals about 4073. And when we tested them both together, we had 3838. So there's about 250 CFM difference between those two tests for total leakage. So that concludes this example. Now we'll review the results we got from that test example we just used. We did a fully guarded test on a 2-unit building, is what this would be referred to. We did a multi-point test with blower fans in each unit. The total of the two, so when those two flows from the two fans were combined, we had 3838 CFM at 50. And then we did the compartmentalization test, where we did one unit at a time to figure out what the compartmentalization leakage was. In this test, we did not open windows to the outside in the adjoining unit, so we didn't have 50 pascals across each wall during the test. So here was our results. We had in Unit A, we had 2288 CFM at 50. Unit B, 1753. And you remember that unit was tested at, the results we had from that test was it was at 52, so we needed to convert that back down to 50. So we came up with 1753 CFM, and we'll explain how we did that. So we had a total flow through both Unit A and B of 4041 CFM at 50. So we can see the difference between our two numbers, our fully guarded test, our leakage to the outside for that entire building, if it were tested as one zone, is 3838, and we had about a little more than 200 CFM higher. So we've got some leakage between the units. So a good way to convert our CFM at whatever it was back to 50 is to simply enter that information in TECLOG3. So we entered remember we need to enter our pretest baseline, which in this case was negative 0.8, and we got that number by clicking on, doing a left click on our baseline period of record, and then looking off to the side on where our pressure was for Unit A, or Unit B it was in this case. So our Unit B pressure, and our baseline pressure was negative 0.8, and then we click on our Unit B when we did that single zone test, our compartmentalization test on Unit B. We click on that period of record and we see what our pressure was. Our pressure was at negative 52.2. We had ring A, and our flow was 1785 CFM at that pressure. So then next we'll go to the results page, and now it takes that information and it converts that airflow to 50 pascals. So that's where we converted from the pressure we tested at to 250. So that concludes the webinar. We will take some time to answer questions. You'll see that we've answered some questions during the webinar, and you can read those. We're going to pause for a few minutes to let everybody's video catch up. Some people will be streaming the video at different rates depending on how fast the connection you have. So we're going to wait so there'll be some dead air time here for a few minutes, and then we'll have a discussion and answer some additional questions and review the questions that have been typed in so far.